we're to present on our proposals to develop a framework for monitoring emerging contaminants in the Lake Champlain Basin. And Dave and I are going to share the presentation today, and we also have some of our team members online. Okay, so the agenda for this evening, we'll make some introductions, we'll give some background on the status of the program, spend some time with an overview of how we've proposed its design, and then related to some subsequent conversation with people at the Basin program, and then we'll leave some time for questions at the end. We feel we've got a great team together for this between Stone, USGS, University of Vermont, and Applied Analysis Solutions. And I think it's worth it for us. I've got Joe with USGS and Dr. Raju Battireddy with University of Vermont on the line as well. So we'll go through and give a quick introduction, each of us, and just to help you understand what we're bringing to the project individually as well as collectively. I'm Les Carver. I've been doing environmental consulting for many years, and much of my experience is related to groundwater and surface water monitoring programs, usually at a regional or multi-state level. And a lot of that work is around pesticides, environmental fate, transport of land applied chemicals. But and I look forward to bringing those experiences to this work. Dave, do you want to go next?
Sure. I'm Dave Braun. I know many of you, but not all. And I've been I just celebrated my 25th anniversary at Stone. And most of those years I've been doing water quality consulting work in Vermont, looking at fate and transport of a range of primarily nutrients, but also pesticides and pathogens. A lot of edge of field monitoring, tile drain monitoring, and some urban runoff. And yeah, that's it. Doing applied water resources projects in Vermont.
Right, and Jody's not here. Stryker's not here to join us, but Jody is an environmental modeler. She has a lot of experience working within the basin on a lot of nutrient transport and other critical water quality issues, and she's bringing that knowledge and expertise to the program for Stone. Joe?
Hi, thanks. I'm Joe Ayotte. I'm with the U.S. Geological Survey New England Water Science Center, and I oversee a group of scientists in the environmental hydrology section, and we do a broad array of studies from water use to water quantity to water quality, and also studies related to human health. And it's over the water quality piece particularly that we came to be involved in this project being run by Stone, and we hope to bring some of our expertise in both laboratory analytical procedures to the table, as well as field sampling protocols, and then of course review and analysis of data that comes back from the labs.
Thanks, Joe. Raju?
Hi, everybody. I'm Raju Battireddy, Associate Professor of Environmental Engineering at University of Vermont. My expertise is in water and wastewater treatment, resource recovery, contaminant fate and transport. We are also developing some sensors to monitor a wide variety of contaminants in water and soil systems. For this project, we are looking forward to work, like analyze samples related to microplastics in different environmental matrices. That's all. Thank you.
Thanks, Raju. And Chris Holmes from Applied Analysis Solutions, not on the phone. And Chris and I have a long history together, working together, and Chris is an expert in remote sensing, spatial analysis. He's an expert in environmental exposure, as well as in particular with down the drain chemicals and their fate and transport. So moving on, to give everybody an update on the status, our team was awarded 2 projects. The one we're speaking to today is the initial one to develop that framework, and we put in a proposal for a second year for 2024 funding, and that proposal was accepted. We've heard via email from Matt over the Basin program that it was accepted, and that gives us extended monitoring, a second year for extended monitoring. And so we're a bit of a slow start in 2023 to get the project underway because of accessing funds from NOAA, funding source. But it's a good thing in a way that there has been a delay, coupled with the proposal awardance for the 2024 work, because it allows us to really step back and take a long view, having not actually done any of the sampling yet, to better integrate both of the scopes of work for each of the funding projects. And we're ready to go. Once the funding is in place for 2023, we will convene the CAC and really hear all sides to develop how best to utilize the resources, funding, and then plan for the best field data collection for the program. Rationale and objectives for the studies, of course, to contribute to the Basin program's opportunities for action, as well as the program's toxic substance management strategy. We'll build on research that has been done in the past, where contaminants, in particular emerging contaminants, have reached aquatic environments of the basin. We'll look at, investigate sources and contributing land uses of the emerging contaminants. It's important to evaluate the risk of the emerging contaminants, both from an ecological as well as a human health toxicological benchmark, because that's really how you judge what the analytical results mean in the environment. And of course, the overall objective is to develop this framework for monitoring, and it will be in consultation with state agencies, the CAC, Basin program, and parties like yourself. And we're definitely aligned towards communication and making this the best program possible. So how do we get there? There's 3 paths that were taken in the, as we say, work plan 1, that's 2023 funding. And one is to have the background development, do the research to know where we need to develop data, and that data development leads to the development of the framework. And within each of those, like I've mentioned, we'll have the project advisory committee, the PAC. We will develop the quality assurance plan, both following EPA as well as the Basin program's guidelines. We will have a look back on current and past literature, do an extensive literature review, and also conduct interviews with state agencies, nonprofits, anybody that's doing work in this area to best design and use those data for the selection of sites, and as well as moving to the next area would be developing the data, where we're actually collecting water and sediment samples in the field, analyzing those samples, and then bringing the data together and developing the framework. The second year is an extension, so we'll continue with the data development, engaging the PAC, amending the QAP as necessary, and continued with the sample of water and sediment samples, analyzing those samples and refining the framework. And of course, there'll be quarterly and annual reporting associated with that. To add a little more detail on the data development, we want to touch on the literature review, the interviews, and the resultant data compilation. So from this work, we'll compile a database of emerging contaminant concentration data, the associated sampling information, which is very important, where it was collected, when it was collected, how it was collected, and we will also catalog the human health and aquatic life benchmarks for reference. We'll assess from the interviews, so there's a literature review and then the interviews, and we'll look at what other people are doing, what roadmaps have they created for addressing emerging contaminants, and what other monitoring is either ongoing or proposed within each of the states for emerging contaminants. Analyze the land use patterns, the physical settings within each of the watersheds. It could be contributing to the wastewater treatment plants, stormwater outfalls, the urban and agricultural streams and bays. All of these data will be pulled together to select monitoring sites at discharge locations as well as in receiving waters. And this is where I'll turn the presentation over to Dave to go to discuss that selection of sites and what we intend to do in those watersheds.
Thanks, Les. I'll just start by saying for the monitoring component of this project, there are some things that are, I think, pretty well defined, and we seem to at least get preliminary buy-in from the CAC when we presented the work plan on these things. And that was, and for instance, the 6 site types laid out in the table on the left. I'm not going to say that's absolutely final, but I think that this is what we're expecting to do. Wastewater treatment plant, effluent, not effluent, CSO discharges, stormwater outfalls, urban and agricultural streams, and shallow bays. I'm going to go into each one of those a little bit on the upcoming slides. So the site types, and I would say there was also, I think, general broad agreement on the chemical classes that we'll be analyzing for. And that would include this personal care products, home and personal care products, pharmaceuticals, PFAS, we all have been hearing a lot about, microplastics, and pesticides. Our primary interest in looking at those things, we're primarily interested in emerging organic pollutants from current sources. So persistent organic pollutants, not I guess our ancient industrial legacy here. We want to know what's going kind of in the water now. At least that's Stone, and I think it's also the Basin Program's thinking. Basin Program staff and the TAC. Not interested again in historic inorganic pollutants. There's quite a lot out there on PCBs, dioxins, arsenic, mercury, lead. We have a reasonable good understanding of the distribution of old industrial sites around New York and Vermont. Not that more won't be found, but that's not really the mission of this project. We're really more interested in those emerging organic pollutants that are coming out, entering rivers and the lake. So selecting sites, there's some considerations, and this is where I would say we're in the zone of conjecture. Until we write a QAP and everybody's happy with the QAP, and we've met with the PAC, at least once. We're not going to settle in on some of the, specific sites and sampling methods, that kind of stuff. I am going to review, I would say, in the next couple slides, our latest thinking, but that's really it. And our latest thinking could well change. Some of the considerations in looking at each one of these types of sites. For wastewater treatment plants, two of the main kind of drivers that we're interested in are the type of wastewater service area. Where is the wastewater collection system located? We've got village centers that can be interesting to look at. A commercial strip probably has a very different wastewater profile. Residential subdivision, institutional like a prison or a school, and urban. And so I'm thinking ultra urban, Rutland, maybe downtown Plattsburgh, those type of service areas. So the other is treatment type. There are the two, I would say, primary types of treatment in Vermont. We've got, I know we've got Wayne on this, and he could school me on a lot of this stuff. But as I understand it, activated sludge treatment plants by volume are the predominant type of wastewater treatment, and in terms of numbers, there are quite a few aerated lagoons. So we might want to look at just those two kind of conditions. CSOs have got a pretty good understanding where the CSOs are in New York and Vermont, and there are 6 communities that still have fairly frequent CSOs in my estimation, and we might look at 1 in each community, something like that. So trying to get some geographic distribution. The main driver there is going to be overflow frequency. We don't want to set up auto samplers, confined space entry and all this stuff, only to have like no overflow events. So we really want to hit, the ones that overflow more frequently are the ones we'd be most concerned about. So that's sort of what would drive that there. Stormwater drainage systems, there are over 2,000. I know a lot of them in Vermont and New York, within this basin. And here we're thinking we kind of want to stratify them into ones that are predominantly urban and ones that and sort of residential. So we, again, different use profiles, different, potentially runoff constituents there. And looking for medium to large drainage systems that don't have dry weather flow. A lot of the time, when they get too big, you're just draining groundwater. That's not really the interest there. I think we're interested in surface runoff. Agricultural and urban streams. We're interested in the intensity of agricultural use. I think we want to sample quite small streams, but named streams, probably larger than a square mile in watershed area. Maybe draining 2 to 3 farms kind of at a minimum. We don't want to be right up into somebody's farm operation where it's clear there's kind of one source. And frankly, if we're looking for some pesticides, and if that farmer in particular isn't applying them, we're never gonna, there's a counter to going too small, and that's one of them. And then urban streams, there are a whole, we've got a laundry list of these to look at, but also looking at urban pesticides and other contaminants. And then shallow bays, and that's probably where we need the most help from the PAC, is in terms of understanding what some of our criteria, some of it's going to be sampling feasibility. Okay, so looking at each one of those areas, Les, can you advance? Wastewater treatment plants, I just sort of went through the criteria we might look at, some of those considerations. And here I've listed 5 treatment plants that might fit the bill. And of course, we want some feedback on the PAC, from the PAC about these. You might ask, why is, Burlington, Maine not on that list? And maybe it should be, but I regard that as kind of a one-off. It's a major contributor, but it's the only plant that operates like that. Whereas these other choices kind of can serve to represent a class. they're representative of more than just their own unique situation potentially. We're talking about 2 events per treatment plant and a total of 9 grab samples per 9 wastewater grab samples. If you haven't read the proposals in detail, you'll find that the sample numbers are pretty small. And Les is going to get into some of the cost stuff, but that's really the driver here. I mean, we have to be really smart about both the sites we select and the timing because the analyses are so unbelievably expensive. So I would love to see 10 times that number. But this is meant to be kind of a higher level synoptic view of what might be coming out, the treatment plants in this case. CSOs, pretty familiar with those. These are the communities that have quite active CSOs. And of those, I think we'd select perhaps 4 or 5 of the most active CSOs that, we distribute around the basin, including Plattsburgh has some that are definitely good candidates. 2 discrete events. This would be all auto sampler work. A total of 8 water samples is what we're envisioning here. And I've got that. So on the far right are these are 2 Plattsburgh's most active CSOs, and really, surprisingly, each one of these would be either one of those would be a good site. Next slide. For streams, there are a lot to choose from. Again, for the agricultural streams, we want to go into relatively homogeneous watersheds with a lot of agriculture. As we go bigger, we get more forest, even if it's the Missisquoi. So, but not too small. And so we kind of regionalized this in our current thinking. And again, not sure that will stand the test, but we've broken the basin down into 4 regions. The Champlain Lowlands on the New York side, Champlain Lowlands, this is everything Burlington up to the Canadian border, and then Burlington south down to Rutland or Clarendon is the Champlain Lowlands south, and then a central Vermont region. And in each of those regions, we're imagining sampling, 3 or 4 streams and potentially compositing those samples, do a spatial composite. Don't pay too much attention to the list of streams. We could add a lot more candidates, but those are sort of some of the notorious ones, if the ones that sort of occur to us off the top. And for the streams, and this is the component that USGS would lead. And they would have to agree with it. This hasn't adequately been explored with them, but we'll take that up in our meetings with the PAC. We're talking about spatial composites, which just gives us a lot more mileage for very expensive samples. I won't go into the details there, but we can get a lot more information for the dollar, frankly, if we start compositing spatially. And then if we find our composites, for instance, are really hot in the Champlain Lowlands South, we can look further into that, those specific component sites that make up that composite. We don't know which of those 3 or 4 streams might be causing those very high levels, for instance, but we'll have a way to go, to kind of zero in on that. 18 water and 9 sediment samples for ag streams and urban streams. We're just trying to see if these numbers can kind of work within what we proposed between the 2 studies. Stormwater outfalls, again, we do exercise a similar regional compositing. There are a lot to choose from, and I've already kind of gone over the criteria, but we're imagining 2 events, storms later in 2023 and also 2024. So those will have to be right on top of. Next slide, Les. And then the last slide is shallow bays. There are a lot to choose from. We want to select 4 where we think we'll have the highest probability of seeing emerging contaminants at concerning levels. And so that's just a list. We're kind of proposing one event. It would be a spatial composite, both water and sediment, a spatial composite across the shallow portion of these bays, from a boat. But and so this isn't a regional approach because we wouldn't have the resources to sample 4 bays in each sampling region. So again, that is just our latest thinking about how to get the most value out of the resources available, unless it's going to get into the analyses.
Okay, thanks, Dave. So for the water and sediment analysis, our approach is a screening method. We want to get the most data we can out of the samples we collect, and USGS has some excellent methods for achieving this. We'll use their pesticide method, which will analyze for the pesticides, insecticides that are of interest to Vermonters, glyphosate, atrazine, and neonics. And that the analyte suite has nearly 350 different compounds. For pharmaceuticals, caffeines, acetaminophen, pain relievers, and the like, USGS has a method that can result in roughly 150 analytes. And for home and personal care products, their wastewater method, which is a kind of a blending of analytes, yields around 220 analytes. So for the samples, we can gain a lot of information about the presence of different emerging contaminants in the environment. And a key part of this also is the lower reporting limits that the USGS has developed through their national work with these types of chemistries. And there's a rigor behind the QA/QC around the samples, so we'll have a lot of confidence in those data. And as Raju had mentioned earlier in the introductions, his laboratory will be analyzing for plastics, for size, shape, composition of the plastics using standard methods. And then the PFAS component will be analyzed by one of the commercial labs here locally. And to point out the other thing is the cost of analysis. While if you look at the table to the bottom right, the USGS methodologies, UVMs combined with a commercial lab, it's around $3,500 a sample. So we have to carefully consider how many samples we need and where because of the expensive resource. And then for sediment, the costs are less, but we won't be analyzing for all of the constituents. Oops. And bringing us back to the main objective, which is the development of the framework. And we will do this with a engagement with the state agencies, DEC, New York, Vermont, Agency of Ag, Department of Health, because we want to create a plan that is inclusive and informed, but then also can provide direction to the agencies about ways to structure and coordinate the monitoring activities. We want to get the greatest value out of the work that's already been being done in the basin and how to grow and expand that as necessary. We'll specify analytes, monitoring locations, sampling timeframes, critical times in the year for various types of monitoring. And we'll estimate levels of effort. What might it cost to collect these samples? What might it cost to analyze them? And overall, a goal is to provide for better understanding of the occurrence and concentration of the emerging contaminants in the basin, and putting them in the context of the sources and their ecological and human toxicological endpoints. So, with that, we move on to any questions anybody has. I think we might have gone a little longer than we had.
Yeah.
I see Lori's hand is up. Thanks so much for that presentation, everybody. That was really wonderful. Lori, I see your hands up.
Thank you. Yeah, thank you, everyone. I'm delighted to get an update on this and know that this project is going forward. And apologies if my questions are about anything you already stated. I was trying to take copious notes, but also had a little trouble with my mic at times, so I may not have heard you all correctly. I work for an organization that's long been advocating for ongoing testing on this. I know it's really expensive and very challenging to zero in on what contaminants you're going to test for and getting the numbers right. So, but very excited that it's moving forward. I'm wondering if as part of this and in future discussions and any writing you do, you can include a very clear definition of emerging contaminants, because I've been in a lot of arenas where we've been talking about emerging contaminants for like 20 years. And so there's always this discussion, what's really emerging? How do we convey that accurately to the public? And I have that confusion myself. So I just, I'd love to get your input on that, but also just encourage that be part of all your presentations, and certainly really defined in any written documents or any outreach that you're doing, so that we can be on the same page there. And I do have a long list of questions, but I don't want to hog the microphone right now. So Denise, I don't know if you need to pass it to anybody else, how you want to do this, or you want me to go through my list.
I'm not seeing any other hands up. Katie, are you?
I saw Hillary come on camera. I don't know if that meant you had a question.
Oh, hang on.
Matt's hand is up.
Huh? Was that Hillary's or was that someone else's? That is Hillary.
Matt. Yeah, Hillary and Matt.
Why don't we do a little popcorn style, Lori, and then if you want to ask your questions kind of in that, but let's have some other questions and then we can come back to you. So I don't know if Matt or
did you want?
Yeah,
did you,
go ahead.
Oh yeah, Matt would be good.
Is it my turn? Okay, sorry.
Sure.
Okay. All right, thanks. Yeah, I don't really have a question. I just wanted to, so sorry, Matt Vaughn, Chief Scientist at the Lake Champlain Basin Program. Nice to see everybody. I just want to thank the project team for coming on, and I didn't sign on until just when Les was beginning, so I don't know how much of an intro this got, but I wanted to point out that this is, I think, a really good example of the committees really working together, because this stemmed from a resolution that you all wrote and signed along with New York CAC, and then the technical advisory committee took it up and tried to move your idea forward. And this is the project that we all came up with as a team. So I think it's a really good project, and I'm excited to see it happen. And also, yes, thanks, Les, for acknowledging that the delays were not the fault of the project team. We're working with a new funding source through NOAA, which is exciting and not something that we're used to dealing with administratively. So it's been a while to get that started, but they've been really great to collaborate with on that. And I think we're going to have a good outcome, even with the delayed start.
Thanks, Matt.
Great. Thanks, Matt. Hillary, go ahead.
Thank you. I know you said that with the shallow bays, you were not as able to spread those studies obviously around the watershed, but I did notice that there was a lot of sort of spatial variety in your CSOs and your streams that you were looking at. And I just wondered if you do find regional differences in the contaminants that you're picking up, or in the concentrations of those contaminants, would the study also sort of parse that information out, or sort of how will that be presented? Maybe if you know that at this point, would we be able to see, I guess, yeah, if there are trends like South Lake trends or clay soil trends, or something that we might be able to work with.
Les, want me to? I at least got my early reaction to that.
Go ahead, Dave.
Okay.
You started moving faster.
Okay.
I have thoughts too.
Well, my first thought is that the resolution, if we found anything surprising, or I think that will be reason enough to say this could be an issue that needs further investigation in the basin. We're never, we would need more time and more samples to say much definitive about mechanisms other than like discrete sources. But if something's showing up that we're not, that's higher than expected, for sure, that's where the kind of the screening comes in. If it's a problem even one place, I think we're concerned enough about it that it rises toward the top of a list. Does that say? Because that might be, Joe, I don't know if you've got an opinion on that either. I think it's higher level than getting to like the South region, Southern Champlain Basin is particularly problematic, and making those kind of statements. But I think if it's a problem anywhere, it warrants further investigation, which is where this all leads to a framework to advise, essentially state governments.
Dave, can I add?
Yes.
Okay. And also, I think it would be interesting once we have these trends from these different sites. It will also help us to identify the source of those contaminants. If it is a new source, then we can clearly say it's kind of an emerging. That's the whole point of this emerging contaminant part of it. If it is kind of related to some kind of a legacy contaminant or degradation pathways, that would help us to kind of identify the sources and what's causing it, what's making it persistent in the given environment, and so on. I think that would really help us. The synoptic sampling will help us to potentially help us to identify the source, where they are coming from and why they are there. Not that. That's all.
And in the selection of locations, not only through discussions, but we'll do some landscape analysis. So the results, at that early stage, we would be able to tie back as, what's in the contributing area, what industries or what types of wastewater treatment plants, are there hospitals, or, what might be the source of whatever is identified. So, but that's part of the work, is to understand what you might see when you go to a location to sample. And there'd be a reason to go to that location as well.
Thank you. That was helpful. And I think of these as being sort of ubiquitous. So I appreciate that we are still trying to find the source and stop them at the source. So thank you for bringing it back around to that.
Yeah. The other thing I'll add for you guys is that a lot of the analytes in the schedules that Les and Dave mentioned are, schedules that were developed by our national laboratory. And so they're used all over the country by other USGS centers and states and organizations that do studies with them. And I'm hopeful, even though it's not a lot of samples, that we'll be able to evaluate the concentrations of anything we see in a broader context that's perhaps national in scope.
Right.
If things are widespread, that'll be very telling as well.
Wayne, do you want to go?
Sure. Yeah, just a general question, and I'm sure this has been discussed a lot with the different groups in the development, but it seems like you're trying to do everything here. You're checking all the sources, and it really comes down to the cost of testing, I guess. A little bit concerned if there's enough budget there to really get representative sampling, to really get some good data and trends. And I'm sure there's a lot of discussion about this when you're setting up the sampling program and frequency to try to back into it, but it seems like we're trying to test for every emerging contaminant, and we're testing every single source, but there's not a lot of testing for each of those individually. So, I mean, was there any discussion about prioritizing certain contaminants in this initial phase and certain sources and maybe going at it on a phase? I'm sure there probably was, but I'm just curious to make sure there's enough data here to really pull out some good trends out of this initially.
Well,
We all have a reaction. Les, you go.
I can help with that. I can help with that too if you want me to step in. This is Matt.
Okay.
okay.
Um,
Go ahead, Matt.
I'll just start with kind of the request from the basin program that the project team was responding to. The main, there's a lot of attention on the synoptic sampling plan and the experimental design here. But really, I see probably the most important output of this project is the framework for the long-term monitoring that will continue into the future. Really, for a lot of these contaminants, we just know next to nothing about what's out there. And so the synoptic sampling is not, I don't think it's going to give us really useful trends.
No.
It's not going to give us much more than it's here, it's not here,
Right.
or point us toward where we should be monitoring and how frequently we should be monitoring into the future and in the long term. So this is really a starting point for us to know how to better invest our resources moving forward. Maybe I'll stop there and see if the project team has anything else to add.
We definitely have thought about what you've said and discussed it a lot. So as the challenge is narrowing it down in what is the constituent that you're looking for. To gain any trends, you're going to need a very fairly focused, either seasonal, time series type monitoring, and that is very expensive labor and analytically in itself. So that's the opposite challenge we have, getting very specific on a particular chemistry. We definitely are taking into consideration what are other people doing in the basin, and Eamon's going to talk perhaps about some of the work that DEC is doing with PFAS. So as we learn more about that, we pull away perhaps of what we may be doing in that same area as part of this program. So we want to consider everything else that's going on in the basin. And another aspect of it is, well, what do the data mean from a human health and an ecotox perspective? So if you've got endpoints, that may be a narrowing for focus, where what it might be doing in the environment based on the concentrations. But sometimes you need that intensive sampling to get at what that maximum exposure would be. So those are just some thoughts that we've talked through.
That's fine. Yeah, thanks. Yeah, I think that's fine. I understand your constraints and kind of where you guys are starting. I just figured that's probably a lively topic of discussion. I'm just curious to get your input on it. So, I mean, as you know, in my work life, I'm dealing with the PFAS and the biosolids and drinking water and the wastewater treatment stuff and the CSOs, and understand some of the sampling challenges and some of the things a lot we don't still understand about some of these contaminants also.
Right.
Absolutely. I would say the guiding principle that we're looking for, applying what we can learn from state government, the literature, and the literature to, predicting where we're going to see the highest environmental concentration. So we're kind of free from having to represent all of the basin. That's not if the kind of guiding principle is we time in space and time, we try to sample in space and time to where we think we're going to see potentially the highest environmental concentrations, water quality concentrations. That does tend to focus things, but yeah, for I would love 10 times as many samples.
Bob, I see that your hand's up.
Yeah, just real quickly, who's doing all the sampling? Is this, I mean, obviously, when you're talking parts per trillion, this is really precise sampling. Is this all going to be done by stone technicians that are well versed in this? And also, how, as someone that has done mesh sampling, including as a federal and state fishery biologist, how are you ever going to smooth for the weather, including for like wastewater plants or anything else? It's going to be very difficult unless you do it all almost concurrently to have, I mean, obviously we know from like phosphorus, a large rain event can be immense compared, you know, statistically compared to just dry weather flows. So basically, who's doing the sampling and that? Thank you.
The sampling would be completed by collaboration with USGS and Stone scientists. And as for the weather, you know, we would want to look at spring events and the results of the spring flush. So the weather would be more unpredictable then perhaps than like a base flow sampling later season in the fall, late summer. So I can't say any more specificity at this point about handling that. Joe or
that's also something where the composite sampling can be useful. If you get a range of flow events, that's something we've talked about in these discussions is either separating out low and high flow or compositing them. That way you can get flow weighted concentration or time weighted, you know, a range of different statistics you can do with those samples. But because we're limited, you have to kind of pick and choose what information you want to go after.
And Bob, we've had discussions about whether we're looking specifically for plants with relatively low infiltration and inflow, or, you know, whether that's really one of the criteria. You know, are we looking for a major, you know, for a major wet weather flow, and then, you know, most concentrated dry weather flow, sort of August condition. But certainly, if you have ideas about that.
Well, one of the two facilities you picked is mine, Bartlett Bay, and that does have very little flow. We have very little inflow, being a fairly new area. So yeah, I'm not saying that was probably a good choice.
That's great to hear, Bob. Okay. I forgot where you landed after you left Montpelier. Yeah.
I'm just concerned about any sort of contamination amongst the sampling. It's such difficult sampling. I fully understand.
Right, and I know they struggle with that right up the road. At parts per trillion, you know, parts per trillion PFAS is just, it's hard for samplers to stay clean enough, not to have sort of an erratic baseline of just cross contamination.
Yeah, to speak to that a little bit, I can tell you from our part, from the USGS part, you may know this already, so forgive me if it's old news, but we collect all of our samples according to our National Field Manual, which is available online. It's public. You know, back when I started, I won't tell you what anniversary I'm celebrating with the USGS, but you know, parts per million was a big thing back then, and then we were all into parts per billion, and now we're, you know, sub parts per trillion, and that National Field Manual has evolved along with it, and our sampling techniques have evolved along with it. But the one common thread is that the quality assurance bears out our ability to follow those protocols and get clean samples by and large. So that's kind of how we'll be approaching it, if that helps.
Great.
Thank you.
You came off mute. Do you want to ask some of your questions? Time do we have for this, Katie?
We are a little bit over, so maybe Lori, pick your best question, and maybe you can follow up after the meeting today.
And Katie, Now, do we have a quorum?
We
now?
do have a quorum now, yep.
So no CAC members are allowed to leave.
Right.
Go ahead, Lori.
Okay, well, I'm resisting putting all of these questions in a run-on sentence, but maybe just a few points. Matt, thanks for reinforcing the genesis of this work, and that's also a recommendation I'd make that be part of every report to kind of note that history. And that was going to be one of my questions. Also wondering, Nat Shambaugh was really helpful to some of us when we were trying to get a better sense of pesticide herbicide impact and what was needed there. I'm wondering if he's on the PAC, or could be, if there's been an effort to involve him. And finally, for those of us who are been waiting for this study for a long time, interested in the time frame, but I understand that, this is going to be a wide, almost not quite scattershot approach, but we're not going to be able to do trend analysis. We're going to get information that we're going to need to zero in on and do subsequent studies. How do we get ahead of that, understanding that those future studies will sort of be built on information you're getting, but is there a way that the Basin program can lay the groundwork for that now, so we don't always have these considerable time lags between, when we really need to do the follow-up study?
Such a great point, Lori.
I have some thoughts, but anybody else?
Did Matt hop off?
He did.
He did.
Dave, go ahead.
Well, no, in terms of groundwork and trying to get, or at least get caught up, I would say, I understand from talking to Eamon, who's probably waiting, that we had a conversation with him last week that there's an interagency committee on chemical management that's probably going to be reconstituted. I think some members of this project team probably should try to get on that. And also that would be, that is any, to me, a lot of this is a coordination between, ag, health, and environment. And that is sort of a body that could at least do that in the near, start working on that again in the near term. And I think ideally we should be a part of it, and maybe then there's more of an organic development into even a interagency program or something of state government with staff, that would kind of carry that forward. But my thought on that, what was the first part of your run on?
Was just that the genesis of this project be part of the report statements in the presentation. I also think that will help you in the future, building support for this initiative too.
Right.
And the follow-up that's so needed.
And you mentioned Nat. I know Nat reasonably well. We did a lot of good work. I don't think there's a final membership I don't think that the PAC roster has been finalized. And that's really a Basin program decision. That's a Matt decision. So, and he's off, so we can't address that.
I will follow up further with Matt too. But Katie, if you can convey that in the notes for this meeting.
Yeah,
too.
Lauren's got it.
Great. Les, did you have a follow-up?
No, I think to add on to what Dave was saying, that there's the state agencies, you have university, UVM, what work might they be doing in the Basin, USGS, and Joe, you can speak to the organization you all have been formulating around Vermont and the Basin program. So I think there's a lot of things that are moving in that direction, and through the course of this work, those conversations happen and planning happens, and for whomever the expertise is or where the resources may lie. Joe, do you want to mention what
Sure. Yeah, I mean, a couple things. I think what Les was just referring to is some of the new initiatives we're trying to move forward with the Lake Champlain Basin program. And to that end, we formed a New England, we're relatively recently, the New England Water Science Center of the USGS. We were disparate state water science centers, and that was it held us back, honestly. So with the support of our director, we formed the Lake Champlain Science Team last year. They tasked me with that, and it's been fantastic. We've gotten to know people like Les and Dave and you all, and we've gotten to know, for example, Nat Schambog. He's been very helpful with us. In fact, we're working with him currently on interpreting and writing up the results of a synoptic study we did through the Wintelak Foundation a couple summers ago, and that's been really fruitful. I mean, he is a wealth of information. It's efficient. You can make a lot of progress really quickly talking with him. So it's been very useful. And then, through the Champlain Basin program, being afforded the opportunity to listen to the science needs and respond to those as a federal science agency has been really exciting for us, and hopefully good for the program.
And we should say that when it became clear, we looked into the possibility of engaging USGS on our team because they've been the science leaders in this area for better than, for pushing 3 decades now. So okay. But yeah, I mean, I remember in the 90s going to emerging contaminant. I guess those aren't emerging anymore, but to Lori's question.
Well, those updates are really helpful. And I'm just wondering, Joe, I think you said it was a New England Water Center of USGS, but
Yes.
I assume on your Lake Champlain science team, you have New York and people involved as well.
We do, very astute. So we really, almost all of us in the agency think of USGS as a national organization. So it's really the high level managers that have to worry about boundaries like New England or New York. And so we work pretty well with the New York Water Science Center and have, we started this science team in New England, but we very quickly made a couple phone calls to our New England friends, and now we're pretty much all around the basin. We could do a little better in Canada, yes, but we're getting there with that too.
Terrific. Thank you. It's a really helpful update.
Yeah, thank you very much. Do we have any other questions for our guests, CAC, or any other guests on the call? All right, hearing nothing. Oh, Lori.
I don't have for our guests, but I do, before we move on to another agenda item, I do want to follow up on a recommendation for the CAC to move forward, because I think we want to do our part to lay the groundwork for subsequent studies, because I am probably, one of the oldest members in this meeting. And so I remember the first contaminant study on Lake Champlain. It was never meant to be the only contaminant study on Lake Champlain, but it was for many, many years until the USGS study. And then we've had just significant lags each time. So, and we can't afford that any longer. And, things that I remember when we were arguing, let's make Lake Champlain the, prevention commercial and be proactive to keep, these contaminants that are elsewhere out of this water body. We are just, very vulnerable to the contamination, but because of our population, we can't draw funds in the same way. So those big studies happen elsewhere. And, luckily, hopefully we won't have the contaminant levels that they're finding elsewhere, but we need to kind of find the sweet spot that we can keep doing studies here and make the case for why they're important, why we need that funding for what is really, really expensive analysis, but critical in order to really inform, our management steps. And so I think that we really want to, just as we hopefully influence this study, we want to get out ahead and make sure that things are in place for the really important follow-up. So I think, I just recommend to the CAC that we, follow this with another resolution and that we get New York, Quebec counterparts to sign on to, and perhaps even more broadly than that, so we can keep the pressure on and our chairs and our leadership have authority in the various arenas that the Basin Program works to keep advancing this message.
I think that's great. I think we could work on that, Lori. I am curious, are you doing this presentation to the Quebec or the New York CAC as well? Right now, are you?
To New York, presumably after we have a contract, but I think that one wasn't written in. That hasn't been scheduled.
Yeah, the New York members were invited to attend this meeting, and several of them were going to attend, but I did also tell them it was recorded, so we might have some follow-up input from them. We are competing with a nice day, so.
Okay. But not the Quebec CAC.
They're differently structured, so I think we can find a way to work with them into this process as well, but they don't have regular meetings in the same way that we do.
Okay, well, I think that's a great agenda item for the CAC, Lori, to put that resolution drafting on our agenda. So thanks for that recommendation.
Thank you. Thanks for a great presentation, all of you.
Yeah, thank you.
Thank you.
Thanks for listening to us.
Of course.
Good luck with Eamon. Yep.
Our job, right, is to get the message out there and have people act on it. So thank you very much. Okay.
Yeah,
Thanks for having us.
presentation.
Yeah. And you're welcome to stay on for the rest of our meeting. It's a public meeting. So if you want to, we're actually, Katie, if we still have a quorum, I'd like to approve the minutes from last month.
Yeah.
So I could look for a motion to approve those, or if you want to pull them up and people can take a minute to look at them.
Make a motion to approve the minutes.
Thanks, Wayne.
April 10th.
Yeah, from the April 10th meeting. Do I have a second?
I could second.
Thanks, Hillary. Any discussion or changes or amendments? All right, hearing none, I'll look for for a vote. All those in favor?
Aye.
Any opposed?
I should abstain because I did call in from Ireland, I remember, but it was only for like 5 minutes.
I'm
And I think that your wife-
abstaining as well because I wasn't able to attend.
Okay, so that's 2 abstentions. Does that still mean they pass? Katie, do we have enough votes for yay? I don't know.
That's a great question.
I think abstentions count as they don't count against the quorum. They should, and I think that's been, that's within Robert's Rules of Order or within the latitude for interpretation. But
Okay.
and
believe
you're
so.
not
That's so
required. You're not required to abstain from a meeting that you haven't attended. It's just, I think, probably Bob's and my personal preference.
All right, well then I think the minutes passed. We have 2 abstentions and I think everyone else approved, right?
Correct.
Whoever's on. Okay, great. And I think the last thing on the agenda, Katie, and I don't have it in front of me, was the upcoming meetings. And
We have another presentation actually. So Eamon Toig's on and he's going to talk about residuals management and emerging contaminants. So we have a nice little theme today. And Eamon, the rest of our agenda is pretty flexible. So I know we ate into your time quite a bit on this last presentation. So please take as much time as you need.
thanks, Katie. I missed that. Sorry.
Well, thank you. That's a dangerous offer. I tend to go over time anyway, so I'll try not to. Yeah, it's nice to be here. My name is Eamon Toig. I work for Vermont DEC. I have for many years now. Been to Lake Champlain Basin program meetings in the past when I was at UVM. I started off working at UVM on phosphorus mitigation strategies, and met Dave Braun that way, and likely met many of you in the past, and I'm sorry if I don't remember all of you, but I guess I'm here today to tell you a little bit about the work that I'm doing in our program at DEC, and also I'd like to just sort of make sure I have time to inform you guys about some upcoming projects that DEC is working on relating to our favorite emerging contaminant, which is PFAS. Full disclosure, I had this conversation with several emerging contaminants groups, NUIPICs, other folks who have contaminants and emerging concern work groups, and I say, how come we always just talk about PFAS? And there's other stuff out there, and they say, well, it's because it's where the money is. So I'm glad to see you guys are working on non-PFAS related issues, and there might be some opportunity with if I work with a little bit with Dave and Les and others on that project, there might be opportunity for us to share some data and maybe cut down on, for example, some PFAS data that they might want to take. But we can talk about that later. So if it's all right with you guys, I can share my screen, and hopefully you'll be able to see everything. How does that look?
I'm not seeing anything yet.
Okay.
Yeah, I'm not.
I'm probably not sharing my screen properly. Let me try again. Nope, that wasn't my fault. Okay. And then I gotta swap the view, I think. How's that?
Great.
Okay. So like I said, my name's Eamon Toig. I work in the residuals management program at DEC. Many years ago, that was part of the wastewater program. I don't even know what year it was, 2015 or somewhere around then, that it was pulled out and put in the waste management and prevention division. And we expanded our program title to residuals management and emerging contaminants. So it's a mouthful. I wasn't quite sure why it happened, but when I rejoined the program, I realized it was because if you want to look for emerging contaminants, you can look in residual materials and you could find them. They're probably one of the most heavily studied media for looking at contaminants of concern. So it does present our program with a kind of a multitask in that we have to assist our municipalities with managing their sludges and assist Vermont with managing septage and things like that. But at the same time, we're also trying to keep an eye on emerging contaminants. And over the years, our program has shifted. I would say at least 70 to 80% of our time is focused on emerging contaminants now. I'm going to bore you a little bit with talking about sludge and septage and biosolids and things like that. And I don't define what all those are in this presentation, but I can tell you that sludge and biosolids are basically the same material, with the exception of a biosolid gets the name biosolid because it's treated for pathogens. So once you've knocked those pathogens down to an acceptable level, which is mandated at the federal level, and Vermont has adopted those levels, then you can become your facility can recycle that material if you have the means to recycle it. I don't want you guys to look too deep on this chart, but we run these stats every year. They're in our solid waste programs. I think it's the diversion and disposal, D&D report. It's always the last page of the report. Sometimes it doesn't get seen, but these are stats from 2021. And what we're looking at, I just wanted to draw your attention to the arrows. So basically what's happening in Vermont is 72% of our wastewater sludge that's generated in the state is actually being recycled. And that is an all-time high. That is, when I joined the program, it might have been reversed in that 70% was going to the landfill. And typically you'll see most states around 50-50. Nationally, it's about 50-50, and that 50 goes to a landfill or incinerator, and the rest actually does get recycled. A large portion of the sludge that's generated in our facilities around the Lake Champlain Basin region they get trucked, they get dewatered, and they get trucked from the Burlington area and or nearby, and they get driven across the lake, and they get processed by Casella's Grasslands facility, and they make biosolids there, and those get distributed in New York. They do not come back to Vermont, and they pretty much stay local in New York. It's a model that's been around for some time. Bob Fisher knows all about it. Most of the folks that work in the Chittenden County facilities have been utilizing that sort of outlet for many, many years. And as you can imagine, being that it's the largest populous center in Vermont, that's really where that recycling number jumps, because that's a lot of material that gets managed that way. And that's why you see that another arrow going to the 46%. That's how much of our state sludge we actually export. So Vermont is pretty much exporting half of the sludge it generates in Vermont. The bottom of that, the second chart at the bottom is our septage management stats in Vermont, and we are one of the highest. I think we might be the highest per capita in terms of our citizens being served by septage tanks, not on sewers and not served by a wastewater plant. So we generate about 44 million gallons. I shouldn't say we generate, we manage that. And by manage, I mean that's hauled by a septage hauler and managed in some capacity. As of 2021, and I'd say in 2022, this number will even be higher. 90% of that, over 90% of that's going to our wastewater plants. So our wastewater plants are serving those citizens who are hooked to the sewer and paying wastewater rates. And then several of our facilities also accept quite a bit of septage from the communities outside of the sewer service area. Like I said, that number is going up probably, and we can talk a little bit about that why later, but I just want to keep moving because this is only my first slide. So let's see, how do I move this along? Okay, so this is how, and I tried to make this as clear as I could, and I've realized that I'm just way too close to these topics, so it might not be as clear as I see it. But these are some management options that are available to your typical US municipality. And on the left there, on the y-axis, you'll see landfill incineration, land application, which is basically biosolids, and then EQ biosolids just means you don't have to have a site-specific permit to land apply that material because you've treated it to an even higher standard where the EPA and the state have said it's safe enough. We're not concerned about the pathogen levels, so you can blend it into, compost mixes and topsoils and typically it's achieved through high temperature composting or some sort of process where it's higher heat to get those pathogens reduced. Bob's facility in South Burlington Airport Parkway generates an EQ biosolid. And then the other thing that happens a lot is people just move stuff between facilities. So you might have a small facility that just hauls liquid sludge to another facility for processing, or like somebody like Burlington who's got a large dewatering facility, they might be receiving waste from the two other Burlington plants, Winooski, things like that. So where I've indicated red basically means that's a no-fly zone, that doesn't happen. Where it's green, it's still technically good to go, and yellow means we're kind of warning, caution. For example, we send sludge to the landfill, and if any of you are following the news in Maine and in other places, you'll know that there's a real crisis in terms of where to put sludge because landfill capacity is a real concern, and there's not enough landfill capacity to be regionally in all of New England. At least there's dwindling capacity. I don't want to say it's not enough, but there's dwindling capacity. I'm not aware of any new landfills coming online. So sticking sludge in the landfill is just taking up space. The seal on the top there, those are the different types of materials that I was talking about. And another one I'd draw you to would be the yellow boxes that say site-specific permit. That's where we would typically see our Class B biosolids, which is, hasn't achieved the high temperature or the high pathogen reduction, but is still a biosolid, or our septage, which can be stabilized with lime. pH goes up, kill the pathogens, and it's basically treated the same way as a biosolid. What's happened over the last 3 years, is that we've started to test all these sites for PFAS, and unfortunately, we've had to close, and/or towns have voluntarily started to close their own sites because we are seeing, after decades, typically, of repeated application every year, we're seeing levels of PFAS rise to the levels where we don't want to continue to use that site anymore. And I'll talk a little bit more about that. So what does that leave? That leaves on the bottom right corner, septage going to all the wastewater plants. It allows people to transfer stuff between facilities, which doesn't really manage it. It's just passing the buck. And then right in the middle there, you've got that sort of larger green box, which means if you can generate an EQ biosolid in Vermont, you have different options. You can land apply it, you can give it away, you can distribute it, you can export it, you can do a lot of things. You can do different things with it. And we still allow that, and it's still ongoing. These are all managed under our solid waste rules in Vermont. Not that anybody wants to go read those rules, but if you ever did, they're there. So I don't want to get too into this because I kind of covered it in the previous slide, but basically I have a summary here of just some thoughts about how we manage this material. I've already mentioned at the very top of that list that we have limited landfill capacity, and Maine has a sludge. I'm sorry, technically they don't have a sludge ban. They have a biosolids land application ban in Maine, which means a lot of material is lining up to get in the door at the landfills there, and they just can't take it all. And it's not a great situation for Maine. If you don't know about it, I would encourage you to look at a couple articles. There's been plenty of coverage at the national level, and also all the local Maine regional papers or regional press is covering it. What else is on that list? So as we start to struggle to find outlets and capacities, especially at landfills, we start trucking things further and further. Obviously, we can't truck anything further east. So things are going west and north. Quebec recently banned importation of sludges from New England or all of the US. So really, we're getting boxed in, and things are starting to ship further and further away, whether it be south to Virginia, west to Pennsylvania, west to Ohio, west to western New York. Anywhere that will take it is basically where people are looking, which is going to result in much higher costs. And these are going to be burdened by our municipalities and our taxpayers in Vermont, who are going to see these costs come at them in wastewater rates and increases as sludge goes from $100 a ton to manage to $200 a ton to manage to, at this point, we don't know where things are going to go. Sky's kind of the limit in terms of that cost. And Wayne can tell you very, very pointed stories of some of our smaller municipalities attempting to do pretty large sludge management projects. For example, they might have to clean out a lagoon that hasn't been cleaned out in some time, and they've got a lot of material, and they are struggling not only to afford it, but to find anybody to take it. So the other thing that we all know about is that, when you put organics in a landfill, you generate methane, which is a pretty potent greenhouse gas, bad for the planet. We got hauling in trucks, bad for the planet. This is all an environmental justice issue. And we've got really no great solutions, to be completely honest with everybody at the table. The state does not have the best solutions for this. The EPA does not have solutions for this. It ends up falling on the municipality primarily to figure these things out. What are you going to do with this material? And I think we need sort of an all hands on deck approach to start coming up with some creative solutions to this, because it's not going to get any better anytime soon. This is a short one because we don't have sludge incinerators in Vermont. It's not really an issue for Vermont. I don't think we're ever going to get in a sludge incinerator in Vermont. I would be floored if we did. But even those that are operating in Connecticut, Rhode Island have problems. They have to shut down for maintenance. They have unforeseen challenges. And when one shuts down, it creates a bottleneck and it creates a backup, because all these entities are working together in some sort of strange harmony and synchronicity that allows them to put material where it can go. And if we start to talk about how we're going to manage PFAS, I think the EPA's research is showing that sludge incinerators are not going to destroy PFAS. In fact, I don't think really there's an incinerator out there right now that we know that destroys PFAS. So we can burn garbage, we can burn sludge, but it doesn't get rid of the contaminants. It just transfers them to air and back down to our waters and soil and us. Land application, which just basically means biosolids gets used as fertilizer. It has its challenges, right? And historically, it's been challenged by the ick factor, odors, concerns for what might be in there. And, you know, we were making some progress on that, especially the ick factor. And here comes PFAS, the boogeyman. Vermont has surveyed every permitted Class B and septic biosolid site we have, and we basically are down to one septic land application site and maybe I would say 3 active biosolid sites. So it's a dwindling practice in Vermont. It's a risky endeavor to go out and try to get a permit for this, and you know it's possible through the rules to do this, but I think it's very uncertain. And I think our municipalities are smart enough to know that it's a very uncertain future, and they're a little bit weary about wading into that uncertainty. And I can't blame them based on what's gone on in Maine and what's gone on with our sort of longstanding land app sites and having to close them. Vermont has done a lot of PFAS work. We are definitely out in front in terms of other states. We had, as far back as 2019, had already, I'd say 2018, had already started to dig into our wastewater plants to look at PFAS levels in our influence, our effluents, our sludges. This is a quick bar chart just showing you the typical levels, and this is being parts per billion. And I know sometimes it's hard to get our heads around units. Typically, when you're talking about water, you're talking parts per trillion. Even when we talk about wastewater effluents, we're typically talking about parts per trillion. But when we talk about solids like soils, sludges, these compounds tend to stick and accumulate and concentrate in these solids materials. So you're talking parts per billion. So that's a much more concentrated. So this chart is a little bit of an oversimplification, but basically just to show that we are testing our sludges and we kind of know what we're getting. We do test any sludge that's managed as a biosolid in Vermont. It's required in the rules since 2020. Paper fiber is something that we're still learning about. Certainly there are some PFAS levels in it. It typically does get recycled. There's some pretty large paper recycling facilities in Vermont and across New England that also do not typically put this material in the landfill. It does have a beneficial reuse potential. It's a lot of material. The landfills don't want it. It's just too much material, and it's actually very expensive to get rid of all of that. If our paper mills in Vermont had to turn around and put this in the landfill, it would probably close them. So this is another busy slide. I apologize, but this is a summary of all the sampling we've done on our biosolids land application site. So we've tested these are numbers from maybe last year, so they've gone up. We've probably tested 150 groundwater wells, and we already had groundwater monitoring wells at all of our land application sites, which made it very easy to go and test them. So we've had, of those 100 and some odd tests, 150 or so, 30 of them have been over our groundwater standard of 20 parts per trillion. So that doesn't, to me, that on its face value might not sound like a lot of them that are over, but all it takes is one well on a field to get you over, and then we pretty much have to close you down. So that's resulted basically in, if you have a well that's over at a field that you're using, you're done. So that site gets closed. So we have closed the vast majority of them. We've done a lot of soil sampling, got some numbers there. You know, background soil level or background soil testing in Vermont has been done, and for argument's sake, if we wanted to say that was 1 to 2 parts per billion background in Vermont, that's just ambient levels. We're finding an average level of about 13 at our land app sites in soil. And we've tested drinking water wells around these sites, and that is the silver lining to this story, which is that we do not so far have any impacts to drinking water supplies. Fingers crossed we won't, and we continue to check, but so far so good. So yeah, we've tested about 30 unique sites, and then there's about 3 left. So that'll show you how many have kind of come offline. So we've got this concern with PFAS in this material. We've got to manage it. We can't put it all in the landfill. I'd argue that while we can certainly export some, you know, I don't know that that's necessarily what Vermont wants to do. The market that we have now with working through New York and Casella is a good thing, but I don't know that it'll always be there. So we're thinking at DEC, how do we make biosolids recycling work, but mitigate additional risk from PFAS? And one thing we're thinking about, and this is in a very, very early, well, first thing we did was we revised our rules in 2020 and required testing for everybody. We also limited the ability for folks to bring stuff into Vermont. So you have to have approval through us to bring stuff into Vermont. Any biosolid in the past, if you were making a high-level biosolid, you could just bring it to any state. No one tracks it, and that's still true today. I'm not aware of any other states that require a registry or an approval to bring stuff to them. But we need to do more. And I think one thing we're trying to think about here is how do we get a better handle, because our EQ biosolids generated in Vermont are not tracked currently and are not required to, and no other state does. We think it's worth doing. So we're going to be rolling out an interim strategy and likely future rulemaking where we basically intend to track and have people report to us where they're taking this material. It's already required to be tested, which is good. And the other question is, you know, getting our head around when is it okay to put it on the ground and when is it not. So I think we're looking at some potentially steps that will be required in order to do this. And it's something we want to try out before we get straight into rulemaking. So this is all still this is still in draft form, and most people don't know about this, but I'm sharing with you guys today. We had a really great stakeholder group that put this work together. Bob Fisher, who is here, or I don't know if Bob's still on the call, but he was part of that stakeholder group. There was, it's been a long time coming. And the very, very last step was a very, very focused group that involved the Department of Health, Agency of Agriculture, DEC, New Hampshire DES, material managers like Casella. We had representatives from Quebec. So it was quite a unique and focused stakeholder group, and this is what's coming out of it. I think ultimately what we're going to probably end up doing is looking at sort of background soil levels and saying, if your material is below that, then you can definitely use it, and if it doesn't, then you're going to need to show us through some basically through some land application calculations what the resulting soil levels will be. So you do like a pre and post soil test, things like that. And again, this is still in development. This is not really ready for prime time, but just wanted to kind of let people know that we're working on this, that we feel we need to find a place between status quo and a straight prohibition. Based on what we're seeing with other prohibitions, they don't work in terms of the big picture, and there's going to be lots of consequences that are going to be that aren't going to be great. So the last thing I want to share with the time I have left here is this is a list of all the PFAS focused projects that we're starting, and there's quite a list here. The project I'm spending a lot of my time on right now is a private drinking water supply testing effort. That's a statewide test that we're just starting. We started it in March. We've already been getting results back. The intent there is to do 500 private testing or private wells to test, to survey and see what kind of, these are places where we would not expect to necessarily find PFAS. There's no known releases, there's no known point source. So this is sort of like, what's the state of the state in terms of you know, our private citizens' groundwater that they're drinking and the potential PFAS contamination. We've already tested all the public water supplies and have reacted to that. So this is the next step. This does relate to our lawsuit against the manufacturers of PFAS. So this is being done in conjunction with our outside legal team. We have a EPA pollution prevention grant that we got. This is the second year in a row, or second grant in a row, that's been focused on PFAS. The previous 2 years were focused on the metal finishing industry in Vermont, which isn't a big industry, but we have some metal finishers that crosses over to the aerospace industry in Vermont. So we look for PFAS there. That report should be out really soon. We had Sanborn and Head and Weston Sampson working with us on that one. Not to spoil it, but the good news is we didn't find a lot of PFAS contamination coming from these industries. So that's a really good news for Vermont, which is in stark contrast to what they found in Michigan, where they had very serious PFAS contamination coming from various chrome plating operations in Michigan, and had to respond with wastewater limits and limitations on biosolid use. I didn't see a lot of chrome plating in Vermont. I guess there's just not as much of it going on, at least at the scale of an industrial scale. We have done wastewater testing in the past, but we are now embarking on a more comprehensive 2-year wastewater testing project. That contract has not been awarded, so I cannot tell you who's doing the work, but we are in the planning phases of that. And that is going to be quarterly sampling every wastewater plant in Vermont. So there's 94 wastewater plants. We'll do a survey. So over the first year, get quarterly sampling. And then phase 2 is going to be, we're going to take that data and basically work with a select group of municipalities based on the data we see to try to do a more intensive sewer shed sampling. Well, we'll pick strategic points in conjunction with the town and work with them to try to see where we can figure out where this stuff's coming from. Is it coming from residential? Is it coming from specific commercial sites? Is there an industrial facility we didn't know about or haven't sampled? I think that's $1.25 million study. The food waste testing pollution prevention grant, which I just skipped over, I apologize. I think it's a $400,000 or $375,000 grant, and that came out of a lot of concern we were hearing from people saying that we're recycling food waste, but there's tons of PFAS and microplastics in it. So we're going to go check, and we're going to work with our composting facilities, our anaerobic digesters, our one food depackager in Vermont, and we're going to look at those waste streams. The full intent of the grant is partly for DEC to get a handle on what sort of levels we're seeing in terms of PFAS and microplastics in the food waste stream. And Agency of Ag has done a little bit of work already on this with UVM. But also, most importantly for us is to work with our food processing industry to educate them on what we're seeing and to try to work together and form partnerships to see if we can make some improvements in pollution prevention. I'm just going to keep going here. We just started that contract signed yet? No, but very close. A statewide septic capacity study, and we, to flash back to my first 2 slides, we talked about how some 90% of all of our septic is going to the wastewater plants. That's a burden on some level that these plants have to deal with. And of the wastewater plants that are accepting this material, there's only a handful of them that take a lot. And several of them are facilities that ultimately discharge to rivers and or the lake. So I think it's really important for us to get a handle on what's going on, because I think we all feel that if we lose a little bit of that wastewater capacity, we're going to potentially have a problem in managing this material. And mismanaged septic tanks are a problem in Vermont. We've been doling out grants trying to get people who low income or whatever, people who are unable to afford to have their septic tanks serviced, get a grant to have them serviced. But that's just continuing to maintain what we have, and I think we need to get a better handle on whether there's some other models that the state should look at to try and manage septage in the state. We have potential soil standards coming, but I think it's way early in the game. The sites investigation rule, the draft rule I've seen that it's actually gone out for one public meeting, does contain PFAS standards in soil for the 5 regulated PFAS. The way those were set is based on our background study. So these are not based on modeled leaching scenarios. These are based on our ambient conditions in Vermont that already exist. So if you haven't seen those and you want to see them, you can ask me or you can Google. I don't know if it's up on, probably not up on Google, but we can get you that information. We're continuing with the surface water fish tissue study. I think Vermont's required to see if we can come up with a surface water standard for PFAS by 2024. So that's ongoing through our MAP program. They did some sampling last year and they're expanding that sampling this year. Still responding to PFAS contamination from the public water supply testing we did, and there's some schools there. There's the Burlington Airport, which is getting an extreme amount of site characterization. I think there's, I forget the number of samples that have been taken up there, but it's in the hundreds, I believe. And then the last thing that I just want to draw your attention to, if you're not aware of, NUMO, New England Waste Management, I forget what the O stands for. They are working on regional draft model PFAS legislation. Some of you probably know that Vermont already has legislation that kicks in July. That's a ban on PFAS in consumer products, including carpets, ski wax. I think it's intentionally added PFAS to carpets and maybe upholstery, and then food packaging, which is a big one. So that also ties into our pollution prevention grant. But there's a public comment period open through NUMOA to June, end of June, on that model legislation, and that would be sort of like, you know, if one state bans PFAS, does it do any good? Wouldn't it be better if we could get together as states and come up with some regional legislation? So I think I should stop, and I'm happy to take any questions if you have any, with the little time we have left. I'm happy to throw slides back up, but for now, I'll shut them down.
Yeah. Go ahead, Wayne.
Eamon, quick question. I should probably know the answer to this one, but any concerns about the biosolids going over in New York from a PFAS standpoint and what the short and long-term viability of that is?
Good question. I mean, so far, we're not hearing anything from New York that says that they're not going to be able to, Casella's not going to be able to continue to take that material. But it's a very good point, right? I mean, when you put all your eggs in a basket like that, if that basket goes away, every wastewater plant in the Chittenden district and the Lake Champlain district on our side is going to have a serious problem getting rid of that material.
I'm surprised. The other thing too, you know, with Casella, you know, and maybe there's some discussions, but kind of wondering why there isn't probably been more activity on the private sector, maybe looking for some better short and long-term solution. That doesn't seem like that's really happened yet, but there's some potential opportunities there. Maybe that's being looked at up for discussion, but that's probably where some of this may be headed.
Yeah, I certainly can't speak for Casella. I mean, I think they've had their work cut out for them with the main prohibition, trying to manage their large compost facility up there. It's the largest biosolids composting facility, I think, in the New England area, if not Northeast. So I think that they're getting squeezed there. I think that's really where they're having to focus right now. But yeah, you make a good point. I mean, I think there's certainly an opportunity. I don't know if I would call it a sludge management crisis, but it's not far off. And I think
I would beg to argue we're already there.
Yeah, we might be. And so, I mean, yeah, there's opportunity for sure. I guess I'd leave it at that.
Yeah, this is Bob. I'd like to reiterate, not only is this currently a sludge management crisis, it's just a crisis at the moment. It is, things could go awry quite quickly where it's far more than that.
Yeah.
I mean, there's all sorts of instances, right? So go ahead, Wayne.
Yeah, and I know this group is really focused on water quality, and you know, I'm dealing with this on a daily basis on the drinking water side, and there's so much we still don't know. You know, what's the migration of the stuff over time? I just hope we're not overreacting to some of this stuff, you know, as far as understanding what some of the short and long-term issues are with it. Because it's everywhere. And I don't know, we've got to figure out some reasonable ways to manage it moving forward.
Right. And this is Bob again. And once again, I mean, my license, everything else is public health, my biology, that's what I do. So I want to do whatever best for public health. But blood levels are over 1,000 parts per trillion in all of us on both PFOS and PFOS. And household deaths is 10,000 to 60,000 parts per trillion. The whole thing's just a nightmare. And that's why we've been going for CERCLA. There's a bill now in front of Congress, because if we're hit with CERCLA on PFOS for the water and wastewater plants who don't have anything to do with it, the Vermont residents will have to pay for all this when it should be on the manufacturers. It's besides that, the septage is just teetering. The cost as it goes up for biosolids disposal and everything else will go on to septage, and people will just stop pumping their tanks more when it goes from 300 to 3,000. It's just really, and besides, me as a municipality, South Burlington, why would I ever risk, if there's a PFOS limitation on my effluent or biosolids, why would I risk an increased cost for the residents of South Burlington by taking septage from an outlying municipality? If I did, I should be fired, I would think. And so once again, it's all like happy rainbows. Thanks.
Yeah, these things are all connected, and I usually make that point early on in this talk, but Bob's absolutely right. I see so many references to wastewater facilities as sources of PFAS, and that couldn't be further from the truth. You know, they are merely receiving and conveying that, and or it's partitioning either into the sludge or the effluent, and there's nothing that we can expect of the wastewater facilities to treat that. It's not viable, the technology, and even if it becomes viable, it will be beyond cost prohibitive.
But once again, though, I'm hopefully more optimistic, even though I'm sorry I was Debbie Downer here. Nonetheless, that it can be treated at the municipal level. The 55% of Vermonters, the most in the nation by population, they're all spreading it in their yard as we speak. That's all I have to say.
I'll just add too, there's so little we still don't understand. Like, I'm involved in some drinking water stuff, and we can't even identify what the sources of PFAS were in some of these areas either. And, you know, how's that migrated over time? What's going to happen to that, you know, as it moves to an aquifer? The groundwater side, and there's so much of that we just don't understand at the moment. So it's really tough to make decisions short and long term moving forward. I mean, Killington's a good example. I mean, they're spending upwards of $40 to $50 million over the next few years to deal with the drinking water issues. So it's a lot of challenges moving forward.
Once again, I just sorry, Bob, one real quickly. To end on a more positive note, though, this whole presentation, look at everyone. They are working together. We are doing an industrial survey. It's in our permits. We are we're moving forward, everyone, to identify the sources of these. I mean, overall, there's just endless because of all of us. But any sort of obviously spike things, any sort of industry, etc. So I mean, these presentations here were great. It just shows how everyone's it's emerging, and we're working on it. And once again, unfortunately, at this point, it can only really be treated at a wastewater facility down the line. When they could come up with the PFAS mitigation on a septic tank, I couldn't begin to imagine.
Yeah, I think those of us who work enough on the waste side, whether you're in waste management, whether you're in recycling, whether you're in the wastewater world, it starts to get a little overwhelming, and you think, well, how do we? Maybe we can't take it all out, but how do we get it? How do we turn the faucet of PFAS that's coming to us off, or at least, decrease that flow? And I think that's where the real learning comes in. Is sure, we can do some legislation and we can try to enforce on that, but there's also a lot of learning and education to do for consumers to get some pressure and push back on keeping this stuff out of products that we use every day. And the more we learn, the more we realize how many applications there are. I mean, this chemical is extremely incredible in its wide application across the board. But I mean, I eat and breathe this stuff every day, and I talk to people about it in my regular life, and they don't know what I'm talking about. So I mean, those of us who are at this table all are in the mindset of thinking about these things, protecting our environment and contaminants, but your typical person, they're not thinking about PFAS. So there's a lot of education that needs to happen, and that's just for, I think, for the things we're seeing in just your typical residential stream of wastewater, which we certainly have isolated residential inputs, and they are not insignificant.
So it is 7, but if anybody else has some questions they want to ask, the rest of the agenda is stuff that I can follow up with over email. It's just I put together a slideshow for the results of the member survey, so I can share that out with the meeting follow-up materials, but I want to give folks an opportunity to ask questions if they do have them. Hillary?
Okay, I have a question, but it's kind of a layperson question, and you don't have to go into lots of detail. But if we do have a state ban on PFAS, I'm just curious, like, is it possible to buy a couch or a carpet without PFAS? And how would we know that those ingredients are in those materials? And say you go buy something from like IKEA in New Haven, how does that work? Just in 2 seconds, 10
It's a
seconds.
very good question. I don't think there is a 2-second answer. Apologize, and that's not my specialty, but it's these things are right. This is like, to me, it's like the ban on putting food in the landfill. That started in it started a long time ago, right? And now it's like everybody knows you don't put your food in the garbage, or at least most people don't, right? And it's gotten better. This is going to be that kind of long-term thing where, you know, you hold the producer accountable by saying you can't sell that in Vermont, or that's why model legislation works. They don't care about Vermont. We're a tiny market. But like if California, New York, Vermont, Massachusetts, all these states say, we don't want you selling PFAS-laden carpets, we are not going to allow that. I don't know if they can enforce on that, but at least there's pressure and pushback on the producers that hopefully, you know, it'll stop or slow down. And one of the things I've been thinking about is certifications. And, you know, there's all these, you know, the organics label, right? Organic, right? It doesn't mean you can't buy conventional, but what it means is you can have a choice. And if you want to buy the organic fruit, you can, and you're going to pay for it, but a lot of people choose to do that. And I think this is could have a similar thing where you, for example, you know, the compostable cutlery, which is kind of a disaster, you know, in my opinion. You get this BPI certification, and then, you know, it says right on it, less than 100 parts per million total fluorine. Well, that's full of fluorinated compounds still. So that certification doesn't really pass the straight face test for PFAS, but it does have some other great things associated with it. You know, clothing, your food packaging, your things like that. If we can get a certification for that guarantees that there's no PFAS in it, then that's a big step. But those certifications, you know, they're not perfect. They're imperfect, but at least they're on the right track.
And hey, this is Bob real quick. And once again, I'm not a complete expert on this, but I think that Amy might be able to back this up. I don't think you actually could stop any of that because the state law would be superseded by federal interstate. But not to throw anyone under the bus here, but basically when you go to Walmart or anywhere else and you get fertilizer, a lot of that comes from wastewater facilities, and you put that on your garden. Or people that compost, there are some people that are say that composting your actual excrement is the way to go. Possibly urine diversion that you could do off, but there are huge public health issues with that. You could never do it to the standard of 104 degrees for over a year. Plus, you also can only legally get rid of that by state and federal at a wastewater treatment plant. So you get even more. So you do all that, and plus you don't understand that 99% of what you get at a wastewater plant is water. It's your washing machines, your drinking water, etc. You know, your showers, etc. It's only about 1% solids, but that's basically it. that there are people that are buying it, you know, for fertilizer, and they put it around the thing. We at South Burlington, we're using it for the airport and for areas that have no human contact even at the moment, although that's about done too. So we're probably going to start landfilling, which is going to be an incredibly huge increase in greenhouse gases. I'm not here to advocate for, but there's pluses and minuses everywhere. Huge though, not to mention they're going to have to import all that phosphorus now, more greenhouse gas, PFAS in that. It's just no happy solution. Sorry, thanks.
Thanks, Bob.
Thanks, Bob.
I mean, we had a great panel on the Vermont Organics Recycling Summit this last week. And we talked about how, yeah, PFAS is the boogeyman, but are we going to let it, you know, are we going to prioritize really, really low risk exposure over climate change, for example? And I'd argue that we shouldn't, right? I mean, we can't lose the forest for the trees. Nobody wants to be drinking PFAS contaminated water. I think we can pull that off, especially in Vermont. But we are going to have to get our head around the fact that this stuff is in everything. It's if you went and dug a shovel full of soil in your backyard and tested it, it would have it in it, right? So it's just, we have to, unfortunately, where we're at as consumers in a society is that if we want to live in this United States of America, we are going to have to accept the fact that there's going to be PFAS in our world. But I am very concerned that it's going to upset our basic pillars of our recycling that we've worked so hard to get. For example, food waste. We don't want to stop recycling food waste, but there's PFAS in it. Certainly, no question. Same with biosolids. We don't want to put all the biosolids in the landfill. We have to find a way to use it in an appropriate manner where we can mitigate risk. And be okay that it's in there and accept that. But it's a lot to ask because it is scary and people are scared of PFAS. There's no question. So I think that that's sort of a high level thing to end on, you know, is sort of, you know, can we deal with this contaminant, as you guys have said, in a thoughtful way, learn about it and tackle it, and ensure that people aren't being directly exposed through things like food packaging and drinking water, and get that low-hanging fruit and get it taken care of. But at the same time, we need to continue to allow our recycling markets to run, and we need to be able to manage organics the way we should, which is to return them to the ground and build soil health and complete the nutrient cycle and do all those wonderful things that every ecology professor would tell you to do. So there, Bob, I finished on a positive note on my soapbox.
There you go. Thank you.
Thank you, everyone.
Just don't go to a PFAS conference ever. You will just sit there at the end just like, oh no. I don't recommend
Or a
it.
climate change conference.
Yeah, there you go. I'd much rather come and talk to you guys at Lake Champlain, and I live right off Lake Champlain, and I spend a lot of time there, and it's why I stayed in Vermont. It's why I took the job I took, why you guys all probably do what you do, and it's a great thing great cause.
Thank you. We think so. And thanks for joining us tonight. We really appreciate it. And
Very welcome.
Katie, great job putting together the agenda for tonight. So go ahead. We can do our business stuff over email. And then we'll see you all in June. And then everybody, I think the July 25th, right, Katie, for our retreat?
Yep.
Is what we've selected. Meg, you just came on camera. Did you need to say something? No, just saying hi to say goodbye. All right, so July 25th, and is that going to be at the Gordon House?
Yep.
Okay, great. All right, have a great day. See everybody in June.
Thank you, everyone.
Thank you.
Thank you so much.
you.
Great presentation.
Yeah, thank
Denise,
you. Great.
I know.
do you have one
Good
more
night.
minute?
Hi, guys.
Who?
Do you have one more minute? It's not a CAC thing. I sent